Hello, my name is Bob Sabo. I'm the watershed specialist at the Indiana County Conservation District. And today we're here at the Sonoma Wetlands AMD treatment ponds to do the Aquatic Ecology station for the Junior Envirothon.
Hi, I'm Cindy Rogers. I'm the president of Evergreen Conservancy, and Evergreen is the steward of Sonoma AMD wetlands and passive treatment system, and we're here to tell you a little bit more about how this works.
Today we're going to talk about abandoned mine drainage, or AMD, and its effect on some of the smallest inhabitants of our local streams, macroinvertebrates. So what are macroinvertebrates? Aquatic macroinvertebrates are organisms that spend at least part of their life cycle in water, are visible to the naked eye, and have no backbone. They include insects, worms, snails, mussels, leeches, and crayfish. Most live on, under, and around rocks and sediment at the bottom of streams. These organisms are extremely important to the food chain of aquatic environments, as they have an important role in the processing and cycling of nutrients and are major food sources for fish and other animals. The aquatic macroinvertebrate community is strongly affected by its environment, including sediment composition, water quality, and hydrological factors. Because the macroinvertebrate community is so dependent on its surroundings, it serves as an effective biological indicator that reflects the overall condition of the aquatic environment. Macroinvertebrates can generally be classified into three categories based on their pollution tolerance, these being sensitive, somewhat sensitive, and tolerant. Some sensitive macroinvertebrates include mayflies, stoneflies, and caddisflies. Somewhat sensitive macroinvertebrates include dragonflies, damselflies, craneflies, and crayfish, and some tolerant species include black flies and midges. So where is the best place to find macroinvertebrates in the stream? Well, the best place is on the stream bottom in the rock and silt, particularly in the riffle. Now, a riffle is a shallower, faster moving section of a stream. Look for areas with fast current where rocks break the water surface. So how do we go about sampling for macroinvertebrates? Well, the method we use is called a kick net, as you can see in the video playing here. A kick net is just what it sounds like. It's a net that you hold at the bottom of a stream, and a second person goes upstream from you and kicks around, or it in some way disturbs the rocks and sediment at the bottom of the stream, and you collect anything that gets stirred up in the net below. Now we do this 3 times for 3 minutes per round, and at the end of each round we check the net and see what we found. Hopefully lots of macroinvertebrates. Now the kind of macroinvertebrates found sometimes is just as, if not more important, than how many macroinvertebrates are found, because finding only tolerant species of macroinvertebrates doesn't mean the stream is all that healthy. But if you have a large quantity of different species of macroinvertebrates, including some of the more sensitive macroinvertebrates, that tells you that you have a pretty healthy stream. One of the biggest impacts on the health of macroinvertebrates in Pennsylvania and Indiana County in particular is abandoned mine drainage, or AMD. And here we are at the Sonoma Wetlands AMD treatment system that is actively treating the water and improving the conditions for macroinvertebrates. There are approximately 85,000 miles of stream in Pennsylvania, and 2,500 miles of those streams are impaired by AMD pollution. AMD pollution is in fact the #1 non-point source of impairment in the state of Pennsylvania. Abandoned mine drainage isn't necessarily acidic, contrary to popular belief, though the pH is a good indicator of the health of a stream. pH range ranges anywhere from 0 to 14, with 7 being neutral. For the pH to move one number on the scale, it is actually a difference of 10 times the acidity. The pH test is a very commonly used test in the field to determine the health of local streams. This is due to the fact that it is fairly inexpensive and very easy to do. Today, we're going to take the pH of some AMD water collected right here from Indiana County and compare it to some liquids you probably all have in your houses at home. These include tap water, 1% milk, orange juice, and household cleaning bleach. So first we're going to take the pH of some AMD water collected from Indiana County. And all we're using to do these tests are some simple pH strips similar to ones you could find at your local pet store in the aquarium department. So all we're going to do is put the strip in the liquid and then let it change color, and it should give us the pH of the liquid. So the results of our pH tests, you can see for the AMD water, it is very acidic, going lower than even this chart describes, which it goes as low as 4. So I would say this is between 3 and 3.5. The results of our pH test for the tap water, as you can see, are somewhere between 6 and 7, meaning that it is very close to neutral and would be much healthier to drink than the AMD water was. The results for our 1% milk put it somewhere around the 6 range, it looks like, between 6 and 7, I'd say. The results for our orange juice pH test, again, are very acidic, actually quite similar to the AMD water. But this is to be expected, as the pH of orange juice is in fact 3.5. So our pH test for the bleach actually came with some unexpected results. As you can see, the pH strip just turned white. But when you really think about it, what does bleach do? It takes the color out of things, and these tests were relying on the color of the color strips. So the pH of bleach should really be between 10 and 11, so it should be very blue, but because of what bleach actually does, it's not going to show us that.
Sonoma is a passive abandoned mine discharge treatment system, and it was built in about 2001 by DEP, Department of Environmental Protection. Let me give you a little bit of history about the coal industry in this area. The first mines were here in about 1900. They're all underground mines, and they are a little bit over 100 feet down underneath your feet here and on different levels. So there's different seams that are on top of each other. The last mine in this area closed around 1962. So these are all abandoned mines that are discharging water into our environment. The problem is that the water rains down into the voids of the mines, and it breaks down the mineral pyrite. This gives us sulfuric acid and yellow boy. The water eventually pressurizes and pushes up. Without any electricity, it will come out of the ground. It could come out in farmers' fields, it could come out into streams directly. But in Sonoma's case, DEP drilled boreholes down into the mine shafts, and the water comes up in the mines. You'll see 3 white tubes down at the end of this first pond, and those are the tubes that bring the water from the mine pools. When we come out and test this water 2 or 3 times a month to make sure that everything's working correctly. So the water comes out from the mine pools with a iron content of about 9 to 12 parts per million. And that would be way too much to go into our local stream, which is Crooked Creek here. We are in the headwaters of Crooked Creek. Before this system was in, water discharged into the creek and put approximately 23 tons of iron into the creek a year. All that red that you see and orange that you see on the rocks in local creeks, that's from mine discharge depositing iron on the creeks. And by now you probably know that that will suffocate macroinvertebrates and harm the fish populations, and there will be no life in a creek because of those pollution issues. The treatment ponds here were finished in about 2001. So water was directed into these ponds. There's about 11 ponds in this system, and the water will filter down through those ponds to the end and go back into the creek with a lot less iron. If the water comes out here at about 8 parts per million, we hope that it will go back into Crooked Creek at 0.5 parts per million. That would be the best case scenario. As the water comes into our pond, you'll see that it reacts to oxygen in the air and in the water, and that helps to precipitate out the iron. So we need it to be exposed to oxygen for a long period of time before it goes back into the creek. Therefore, it will go through all the ponds in the system. So let's walk down so we can get a look at some of the ponds later on in the system. The water runs through this passive system into several ponds. Sometimes the water flows through pipes underground, but most often it goes through channels like the one you see on the right side. The first ponds are the settling ponds where we hope most of the iron drops out. And then the ponds get a little shallower, and at the end are the shallower, more true like aerobic wetlands. You'll see a few plants start in these ponds, but later on you'll see the ponds look like they're just a mass of plants. At the end of this pond, you'll see a yellow baffle which slows the water down and spreads it out, which gives the iron more time to drop out. You'll also see a mass of wetland plants that were planted here for the purpose of helping to slow the water down, and also the iron helps accumulate on their roots. This particular plant is a Burr reed. Evergreen was founded as a grassroots organization. We are an all-volunteer organization, and we are very lucky to have a lot of dedicated volunteers who help with our environmental projects, our environmental education, and our field work. We need volunteers, as does all the watershed groups in the county, to do various projects. You can help by volunteering with those groups and helping to be a steward for your water and land. The water has come through the system, and now we're at the end where the water goes back into Crooked Creek with much less iron content than when it came out of the mine pools. It typically takes about 16 to 24 hours for the water to move through the system. Before Tenoma was in place, there was no life in the creek. There was no macroinvertebrates or fish. Now with Tenoma in place, there are fish back in the creek, and there are macroinvertebrates that show us that it's a healthy stream. We see great blue herons sometimes when we come out here, and we see turtles and other things that show us that there is life in this creek.